In this video, I will be showing you how to use the storage as a caching layer for your integration. This is useful for accessing frequently requested data without sending actual requests to external systems. This helps you to improve the performance of your integration. A use case for this would be storing the address information of a user in the storage to prevent flooding the external API with requests. This is also the example I will be showing you in this video. So as we can see here, we have the incoming data from our system, which is only a user ID, and the output should be a user ID, but also the address of this user ID. For this, we will be using this API that returns information about this user. As we can see, it returns, aside from the ID, we can also access the address information. What we are going to do, we are going to build a transformer that's going to request the data once from the API and then store it in the storage. So for each subsequent execution of the transformer, the data will be read from the storage instead of sending an API request, improving the performance of your entire integration. So for this purpose, I've already went ahead and created a directory storage. And I will be using this directory storage inside this transformer. So the first step is to select the data transformer because we want to do data transformations. What I'm then going to do, I'm going to select the merger transformer because I'm going to first read the data from the storage because we need to know if the storage is empty or if the storage is filled with data. Then I'm going to select the get entity from the storage transformer. This allows me to read data from the storage by a certain ID. So in this case, that will be the user ID. Then I'm going to select the storage that I just created. The ID path should be the path to the field that holds the unique identifier for your data. So in this case, it's the user ID field. So I can just paste it in here. Then I have a template, and this template basically tells Alumio where to store the result of the storage. So what I'm going to do here, I'm going to define here the storage data key. And the value of this should be this James path notation, which we are using inside the platform. Now I will test the transformer, and as we can see, we received an empty array. So this means the storage is now empty. This is also a trigger for us to retrieve the data from the external API, and after that we can write it to the storage. So what I will do now, I will add another transformer, but now I will add a conditional transformer. So we only want to execute the transformers we are going to configure within this conditional transformer when the conditions are met. So first we have to define the conditions. We can do this by adding a filter. I'm going to select the value condition, and we are going to do a condition based on this stored data. So I'm going to select the key accessor and add the stored data key. So now I can make a check based on what's in the stored data. And I will do a condition is empty. So what will happen now if the stored data is empty, so the storage does not contain any address information, we are going to execute these transformers. So what we are now going to do, we are going to request the address information from the external API. So again, I will be using a merger transformer. And now I will select the HTTP transformer. What we now can do, we can take this URL of the API, we can paste it in here. And now we can use this notation to make the input, the user ID dynamic. So what's going to happen now, it will take the user ID of my data and send it to this API. I will select the default client. I will define a template. So what I'm going to do, I'm going to write the address information directly to the address key. Now when I press test, we can see that we retrieve the address information of this API. So the street is Katy Turnpike, and when we verify it here, it's also Katy Turnpike. Okay, so now we have the address data, and what we now want to do, we want to store the address data in the storage, because the next time I'm going to execute this transformer, I don't want to send an API call to the external system. Instead, I want to be receiving the information from the storage. So the first step is to make this identifier a string value, because the storage requires it to be a string. So for this purpose, we are going to use the value mapper. We are going to define a key accessor. We're going to add the user ID key, and we are going to simply apply the cast string mapper. So now when I press test, we can see that the user ID has become a string, and now we can use it as an identifier for the storage. So the next step is to define the write content to the storage transformer, which uses an accessor with which you can tell Alumio what field should be used as identifier for this data. So we are going to use the user ID key for this. Then we need to define the storage where we want to write the data to. So I'm going to select the one that I previously showed you. Then we have the storage path. So where in the storage should we save the data? So in this case, it should be address. Then we have the source path. So where is the data coming from on our current object? So this will also be address, because address contains the information we want to store into the storage. And now when I press test, it will go through. But now when I go to the storage and I go to entities and I refresh this list, we can see that we have a new entity within the storage with identifier 10. And this also matches our user ID we defined here. And now when I open it, we can see the address data is now in the storage. So now when I go here back to this and I run test again, we can see that the address was now retrieved into the stored data object and no API call was done. And now I can simply move this data to the level where I need it to be. So I'm going to apply a move transformer. I'm going to move it using a pattern. I'm going to move stored data to .address to simply address. I'm going to press test. Now we have the address here. And now we can filter away the stored data key. And then now we have a caching layer realized within our integration. So instead of always requesting data from an external API, you will be now only requesting it once, and for each subsequent request, you will be reading it from the storage. Okay, to summarize how to use the storage as a caching layer, we will be going through this transformer once more. So the first step is doing a merge transformer to reading, and which uses a get entity from a storage transformer to read the data from the storage, because we want to know if the data is already present in the storage. For this, you will be using the unique identifiable key of your data. So in this case, it's a user ID. If you're working with products, you would use a product SKU. If you were working with customers, you would be using a customer email address, for example. Then we are applying a conditional transformer, which uses one filter to define when this transformer is being executed. And this filter is going to check if the stored data, so whatever in the storage, is empty or not. If the storage is empty, it will execute this series of transformers. So the first transformer will be a merge transformer that uses an HTTP transformer to retrieve the data from the external system. So this will be the only time when you are going to ask the external system about the data. The next step is mapping your unique key to a string. So this is not needed for all cases, but in this case, we are working with an ID, with an integer, so we should cast it to a string. If you were working with a customer email address, it's already a string. You don't have to do the steps, so it's optional. The next step is writing the content to the storage. So for the next time we are requesting the address for this given user, we are not going to send the API call again. So for this, you define an accessor with a unique key. So in this case, it's a user ID. For a customer, you would use the customer email address. Then you're going to define the storage that you're going to write the data to. Then you have to define the data that you want to write to the storage. So in this case, the address. But if you're working with a customer and you want to store his name or his, whatever you want to store about the customer, you can use those details. So just use your imagination. Then the next step is moving whatever is in the storage to where it should be on your object, and then filtering away the storage defined key.